This is part 2 of the video lecture that we started earlier. This one will be on describing single variable distributions. When we look at the distribution of pulse rates that we studied today in class, we want to make sure that we keep SOCs in mind. We want to talk about the shape, the outliers, the center, and the spread. Also remember to connect your concept to context, your 3 C's. Please avoid phrases such as the data and the graph. Use the distribution of a particular variable name. Also important is to choose appropriate summary pairs. You want to make sure that when the distributions are skewed, you're using the median and the IQR. And if they're symmetric, you're using the mean and the standard deviation. Go ahead and download this template from the blog if you haven't already. Pause the video while you do so. And let's take a look at this template. This is one that you will use every time. These are my words, and you can change it to fit your writing style if you want. You don't have to say these exact things. This is just a really good template to use. So we'll start off with the distribution of, and you would insert the variable name here, is, and you'll describe the shape here, either symmetric, skewed left, or skewed right. And then you want to talk about what this indicates. Remember that a distribution that is skewed to the left has a peak on the right-hand side. So what we see in a skewed left distribution is that most of the values are on the right or in the upper ranges, and very few values are in the lower range. On the other hand, when a distribution is skewed to the right, what we have is a bulk of values on the left-hand side and very few values on the right-hand side, indicating more students or more values in that lower range. If the shape is symmetric, then we indicate that we typically have the bulk of the values in the middle of the distribution and very few on the ends or in the tails. Then we go on to talk about whether or not there are any outliers. Make sure you show or have shown somewhere how you verified those using the 1.5 IQR rule. Name the outliers. Talk about the typical variable name. In this case, it'll be pulse rate. Give the value in units and tell whether you're using the mean or the median. Please do not talk about why you're using the mean or the median. That will be evident in your choice as to whether or not you understand which one is correct. Talk about the spread being consistent or inconsistent. If the value is large for the standard deviation or the IQR, and that's large relative to the context, then we're going to use that are not consistently spread. If these values are small, standard deviation or IQR according to the context, then we'll say that these values are consistently spread. What I did here was pull in some screenshots from the calculator from the last video and what we did today in class. One variable statistics will get you the mean, X bar, the standard deviation, make sure you use SX. So we want X bar for the mean, and we want SX for the sample standard deviation. On the right is the 5-number summary. That's useful for the box plot. And then on the bottom, we have the screen showing you how to make the modified box plot, a window change here that will get you a final graph that you see on the right-hand side, again with this square being the outlier. Notice that that's also the maximum value as discussed in the last video. And so with that, let's take a look at our description. The distribution of pulse rates of students in Mrs. Young's AP classes is skewed to the right. Notice that I've used the variable name here, pulse rates of students in Mrs. Young's AP Stats classes. I've shown you the shape is skewed to the right, indicating that these students tend to have lower pulse rates. This is saying that the bulk of the pulse rates are on the left-hand side, and so that's why I can talk about this tendency for lower pulse rates here. There are a few pulse rates in the higher ranges. I'm moving into talking about unusual values, 100, 102, 103, 110, and 120 beats per minute. However, only the pulse rate of 120 is an outlier according to the 1.5 IQR rule. Now, I'm not showing that here because we showed it on the last video. but you can go back and look at that to see how that was verified. Moving to the center, the typical student has a pulse rate of 72 beats per minute as measured by the median. Because this distribution is skewed, I have to use the median as the measure of center, but notice I don't say why I'm using the median. Just by that choice and by correctly indicating the shape, I'm making a connection between concepts that I understand what's going on. Lastly, the spread. Yet the middle 50% of pulse rates are inconsistently spread around the median. This is evidenced by the IQR of 19.5 beats per minute. We have almost a 20 beat per minute difference between Q1 and Q3, which is rather large when we're talking about beats per minute. If we're talking about SAT scores or salary, $20 or 20 points doesn't make a big difference, but in this case, beats per minute does make a huge difference. So that's the end of this video. In class tomorrow, you'll be working on applying these concepts, and you can always hope for an ICE day, and then you'll just be practicing over the weekend with WebAssign. I hope to see you guys on Monday. Be safe.